So let's quickly, oh, sorry, not this one. Let's quickly revise, okay? So just to make sure that when we start, we are on track. So what is clustering? Grouping, right? Based on distance, or we can call this similarity as well, right? So nearness in whatever form that we can say. So similarity, dissimilarity is a very important concept, and we said that this distance can be based on anything. It could be based on color, it could be based on physical distance, or many other characteristics, right? Did I show you this last time? No, I don't think so. So I think there's something called clustering versus classification. So let us just look at this quick animation, and then we'll see what is the difference between clustering and classification. So clustering is grouping without supervision. So you let the algorithm try to find groups. Okay? But in classification, you guide. For example, here you're guiding in classification. Let's classify based on, for example, here, what is the basis of this clustering? 2 legs, 4 legs, maybe?
Yeah.
Here,
Different species.
different species, right? So the outcome may be different, right? And we have talked about some of those things. Okay, so we saw this example. Data segmentation is another name for clustering, because you're segmenting them, putting them apart based on something. And we saw some math, right? That normally data is provided in this form, which is a matrix form that has n objects with p characteristics, right? So you're looking at multiple characteristics, like in the case of that animals, you can look at their legs, or you can look at their weight, you can look at their size. P characteristics, n objects, right? Tuples. So we talked about tuples, right? Databases, yes.
It's like tuples and attributes.
Yeah, so tuple is like this, right? And attributes are like the columns. It's exactly the same thing. Then we identified a measure called D, which is a matrix where you're looking at distance between any two tuples or any two objects. So when you say D3, 2, so you're looking at finding the distance between
3 and
2. Yeah, object 3 and object 2, right? And we saw last time, but we will look at it more closely, that we use something called I was showing you how physically it looks like, but we referred to the formula called Euclidean distance to measure the distance. And what was the formula for it? It's like
x minus y square.
not x minus y. You compare x with x, y with y, z with z, and so on. So you can see it here. So it's like you compare apple with apple, oranges with oranges, right? So always same attribute with same attribute.
Here, x1 minus x2, is that correct, or x2 minus x1?
Look, when you're taking distance between 1 and 2, and you're taking distance between 2 and 1, it's like you're asking what's the distance between Khobar and Riyadh, or you say what's the difference between Riyadh and Khobar.
Absolute value.
Because you're taking square or absolute value, so at the end it doesn't matter, right? But if you're not taking absolute value, then it does make a difference when you say 1 versus 2 or 2 versus that, right? So you can see it here. What's the other option? Other than Euclidean distance, what's the other option? We said something called Manhattan distance, where instead of squaring it up, the two x's and y's and z's, you take absolute values, which again comes down to your question. It doesn't matter whether you write x1, x2 or x2 minus x1. Okay. So now if that is clear, then I think we are ready to go and talk about the next lecture. Okay. So let's just go a little bit deeper into what clustering is. So far, I told you clustering is grouping, but it is more than that. You know, the way you group can be different, even within unsupervised approaches. Okay.
An example.
Yeah.
Example.
You'll see the example in a bit. Okay. So first we understand that clustering is about grouping.
Yeah.
But the way we group, now we'll talk that the way we group can be different, even if it is unsupervised learning. Okay, so this is what we will inshallah talk about it today, and you'll see all the examples of those different things. Okay, so there are at least 3 major categories of how you do clustering. When I say major categories, each category can have some approaches with small differences. You understand that? So it's not just one type. Within partitioning, there can be different ways of partitioning. Okay, so I'll talk about that. But at least 3 major groups of how you can group items or cluster items. Okay, so what are those 3 types? Partitioning. You can take partitioning approach, or you can take hierarchical clustering approach, or you can do what is called density based approach. So all 3 look very different. Yes.
What is partitioning method? Hierarchical, we know this.
That's the whole lecture.
Uh-huh.
So we'll keep talking about all of them. Okay. So eventually all of them will come. Okay. So first you understand that there are 3 major big chunks of how you group items. Okay. One of them is called partitioning, hierarchical, and density. Even if you know partitioning better than hierarchical, because you know how hierarchy looks, but you don't understand what that means.
What hierarchical ranking?
No. But in terms of segmentation, you need to understand it much better. What does that mean? Okay, you know how it looks like a tree.
Yeah.
But in terms of clustering, what does that mean?
Or like pyramid.
Or like pyramid, but what does that mean in terms of grouping? That's what we have to understand. Okay, so density based. So let's start with partitioning based. So classifying clustering approaches into these 3 groups is what we'll understand, and we'll see what is the difference. Partitioning method is what we have been discussing so far. Is actually whatever we have been discussing so far is actually partitioning, where we are breaking down items into groups. So what does it say? Given a database of n objects or n tuples, a partitioning method constructs k partitions or k clusters of data, where each partition represents a cluster. Okay, and why does it say k should be less than or equals to n? What is n? Number of objects, and k number of clusters. Clusters, k is clusters. Just remember, from k means k clusters. Okay, so I think this one is pretty obvious. K cannot be more than n, which means that at most each item is a cluster in itself. But you cannot have a cluster without anything.
And
right?
represent what?
I'm saying that what is if you have 10 people, maximum how many clusters can you create?
2, 3, no, 10.
10 maximum.
Yes.
Imagine each one, you're calling them a cluster. Cluster with 1 member.
Yeah.
Even though it doesn't mean anything, but maximum how many partitions can you create out of 10 people? 10. So this is what it says. K cannot be more than n. Okay, so it typically requires the number of partition to be predetermined. It creates initial partition which is improved using some iterative technique which moves objects from one group to another. So what does that mean? So if you are the class, the initial step is, let's say I want 2 partitions. So I'll randomly just separate two group. This is how the partitioning method start. You understand? First step, there is no basis, random. You group, and then initial partitioning is random, but then you have an iterative method where you say, this one doesn't fit very well in this group, so you move. This one doesn't fit very well, so you move. So you go iterative. Iterative means you go in a cycle and you keep improving and improving and improving till you cannot
You got
improve any.
anymore.
Accuracy.
Yeah, till you cannot improve anymore. Till you reach an accuracy where I cannot find any other improvement in my clusters. Right? You understand how it works. So you start randomly and you keep improving and improving and improving till you cannot find any more improvement. What does that mean? That will be not this lecture, which is lecture 3. The lecture 4 will actually go through this particular process. Meaning that you'll have the data, you'll have your calculators, you'll have your algorithm with you, and you'll go through these iterations to find a point where you say, "Khalas, I can't improve any further," and that's the ideal clusters you have. Okay, so this is called partitioning. Again, you may have to look at an example, but there are few important things. Each clustering in partitioning method must satisfy two conditions. Each group must contain at least one object. Of course, there is no member in a cluster, there is no cluster. Right? That's the obvious one. Each object must belong to exactly one group. Meaning that you cannot be a member of both. You can either be member here or there. That's one of the rules that you have to follow. Okay? So if you are like 20 people right now here, each one of you can be either in this group or in that group. Now this is the standard partitioning method, but there is a note down there. What does this note says? In something called fuzzy clustering approaches. Fuzzy clustering has very specialized applications, but fuzzy, you know the meaning of the word fuzzy?
No.
No, not random. Fuzzy means unclear. It means that maybe here, maybe there. Right? So in such cases, some borderline points may be here, maybe there. But that is, I'm only telling you because so that you know that such things exist for specialized applications. But for now, after saying this, I'm going to take this out. I'm going to say that we are going to stick with this one, either this or that. No more confusion. Okay? So that's the approach we'll take. So let's see how this iterative approach works, just for you to see and visualize, how this iteration works. So if you are making a cluster of size 2 for this data point, it's like randomly, it just randomly picked C3. You can see iteratively, do you see it's iteratively trying to improve its cluster. So just visualize, how randomly starting somewhere and eventually trying to improve itself to create clusters that makes most sense, right? So this is how it will work. Eventually, even if you're doing clustering, it will go like this.
Yeah, so iterative means moving from a grouping.
No, iterative means doing something in cycles again and again and again. Right? So iteration means you repeat till you get what you want. That's called iteration. Okay? Have you done in programming loops? So iteration is loops. You do something in loops. For loop, while loop, right? So this is iteration. So can you visualize how it's working? So you start randomly, and then after starting randomly, the algorithm should be able to every time get something better. Every time it gets something better. So but at the end, what you have are partitions: 2 partitions, 3 partitions, 4 partitions, 5 partitions, right? Sub partitions. But this is what you already know, because this is what I've been talking about, at the beginning. It is all about partitioning, right? But there are now I'll talk about some partitions that are slightly different. So hierarchical, hierarchy looks like a tree. So let me tell you one single term which will help you understand hierarchical clustering. It is clustering of clusters. Clustering of clusters. Meaning what? Let's say I'll divide this class into 5 clusters, okay? These 2 clusters are very close to each other. So first, 3 of them went into one cluster, 3 of them went into this cluster, 2 in this cluster, and so on, right? So you create initial partitions. But even after creating those initial partitions, do you agree that these 2 clusters look closer than you and the other cluster? Because you two are close. these two clusters are close. You understand that? As compared to another cluster which is far. Maybe these two clusters look close, right? So I can go one level up. I create initial clusters and I say even after creating those first two clusters, these two clusters are the next level clusters. So I cluster the cluster, right? And then cluster, we keep clustering upward till we bring everyone in. And where is the application? This is where you need some examples. But in this hierarchical clustering, what is the smallest cluster? The smallest cluster is one data point. You understand? Unlike k-means or the other partitioning method,
What do you mean by 1 point?
1 point meaning that how many people are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 students. So we start by assuming that we have 16 clusters. Each cluster carrying only 1 point. And then you join the next to one by saying that this is the next level cluster, the next level cluster, and you keep joining them together. Okay? Let's first visualize what happens, and then I'll tell you where is the application. Okay? So this is your data points, and I'll show you even an animation which will help you understand. So how many points you have?
6.
Each one of them are individual 6 clusters. But then these two and these two are like very close to each other. So you call them a cluster. Now the next level, you compare this cluster and this single point cluster seems to be the closest one, next ones, right? So you're putting them together. What next? Maybe these two, and then the rest. Now, why are we doing that? And there are things mentioned here. I don't want to discuss that now. Maybe I'll discuss that towards the end. But let us just see how it works. Okay, first visualize. In terms of the hierarchy, you're more, I think you're used to seeing hierarchies like that, right? I hope it stops. Otherwise, I'll open a new figure and I'll tell you how powerful this figure is in terms of finding similarities. Let's see if how far, whether it stops or not. I hope it doesn't start again. Okay. Now, I was expecting this to restart this GIFs. So let me just open another figure, and I want you to see something, okay? That's my Twitter. Oh, I don't have my internet connected. Let me show you something else. Maybe a pre-made. A real application of hierarchical clustering, okay? Someone is using that in research. Oh, don't look at the quiz. Not for you. I hope you don't have a friend in YU. Okay, so you need to understand why we do hierarchical clustering, okay? So I'm going to show you an example which will help you understand how it works. And so we were analyzing literature in an area called gas supply chain, gas transportation. And we wanted to analyze, what major work is going on. So, do you see these two big chunks?
Yes.
It means we were able to see that this whole literature is actually divided into two big chunks.
So it is.
At least we know at the biggest level there are two big chunks. And we discovered that one of them is called demand forecasting and the other one is called transportation. Can you see how easy it is to visualize? Then within this chunk, how many big chunks do you see? 2 more? Can you see these two big chunks, two big groups. And then within this group, can you see two subgroups?
This one is the hierarchical, right?
Yeah, this whole thing is hierarchical. And then how many do you see? Do you see maybe like one? It's not showing everything, I think. You know, some are, and by the way, this one, the farther they are, the more different they are. So, and I'll give you one more example. You are all students. Do you all agree? At the top, IAU. Then there are College of Business students, College of Engineering students, College of Medicine, and so on. Next chunk, right? Then within College of Business you are MIS Finance Accounting. Then within MIS you are senior, and first year and second year and third year, and then and so on. So this hierarchical approach allows you to see all sorts of grouping within your data, not just one level, right? So it is a very, very powerful approach. Another example is where people are using this hierarchical clustering to categorize web pages. They used to be web directories which people use less because Google, etc. have become very powerful. So a few years back, they used to use hierarchical clustering to create web directories, meaning that if I have to search for a university program, I used to go, instead of going to Google, I used to go to Yahoo search. And they used to be directories. On top of it, they used to put only the bigger ones. Universities, click. Education, universities, business schools. So I can go and go to those group of pages. Everybody understand? So it's not partitioning, it's multi-level partitioning. Right? Starting from single object to everything together as a whole. Right? Can you see the difference between the two? Simple partitioning versus hierarchical partitioning, right? Groups, so many groups. Okay. Oops, keeps coming there. Okay, not this. I hope you don't have any friends in YU.
You mean Yamama?
Yes. Okay, let's get back. So you understand two types. There's a third type as well. Okay? So we do understand a partitioning approach, and we now know the hierarchical approach, right? Clusters of clusters. Okay. By the way, what's the relationship between partitioning and hierarchical? The initial big chunks that you made, do you see at the top the initial big chunks, the two big chunks? If I use clustering, it creates those big chunks. The highest level breakdown is done by the simple partitioning method, right? So if you just need that high level grouping, you use k-mean. But if you need sub, full in-depth analysis, then hierarchical is the option, right? So now there is a third one, which looks like partitioning, but it has a completely different application. And this is called density-based clustering.
This on population.
Can be used for population, many things.
Heat maps.
Maybe heat maps. Let's see, what's the difference between partitioning and density-based. Then I'm sure you will be able to come up with a lot of examples, okay? So, distance-based clustering methods can only result in spherical shape cluster. When you say distance-based clustering, we are talking about partitioning.
What does spherical shaped cluster?
What are spherical shapes? You tell me what is spherical shape.
I don't know.
What is sphere?
Fair.
What is a circle?
Sphere is a 3D circle.
Sphere is a 3D circle. So the general term. But when you use clustering, usually, do you see that when I showed you animation, you can actually draw a circle?
Yes.
You remember when the animation was going on, k equals to 2, k equals to 3, k equals to 4?
Yeah.
They all look like circles. You can draw circles around it.
So circle is a 3D circle?
Sphere is ball.
A ball.
Ball. You have it.
Yeah, I know
ball?
what's a ball.
Football.
Yeah, a ball.
That's a sphere. Yes.
I think the meaning in English for cluster is the part of the graph.
Part of the
Graph.
what is graph?
Tape. Sorry.
Say again.
tape. عقود العنب. عقود يعني cluster.
Aqud is aqd is
No. The part of the grape.
a grape. Oh, okay,
Grape.
okay.
Yeah.
Okay, grape. I understand. Anab.
عنب. Yes.
The one, the hanging, the
Yeah,
one that
this
is hanging.
is the cluster.
Yes.
The grape has so many roots. So
Yes. Maybe that's like the binding thing that puts them together. Now, density-based clustering in distance-based clustering, not density-based. Distance-based clustering, like what we have discussed so far, it looks for nearness, and usually it results in only circle where those groups around which you can draw a circle, right? I showed you k equals to 2, k equals 3, and they were all like drawing circles. But before going into the detail, do you think that this looks like a circle?
No.
You cannot draw a circle in this form, right? So, first of all, they are not very good when actually it makes more sense to draw clusters which are not in spherical shape. And where do you find that? Like you said population? Who said population? Population, do you see population can go like this, right? In different shapes. Does not have to be city, does not look like a circle, right? So it could be like a locality like this, right? An L shape maybe, whatever shape, arbitrary shapes, right?
not
Victor?
exact circle, so
Not exact circle,
it might
right?
be a line or something.
It could be a line, for example, along the coast there's population going like this, right? It's like a line, right? So,
Victor,
yes.
I did not understand what you mean. For it's not like a circle or something.
Can you draw a circle for me on the other side, red one? Does
No.
it look like a circle?
No.
When I showed you this example, did you notice that everything was represented via a circle?
Yeah, everything was circled.
You know, you are drawing a circle and then inside the circle you have everything,
Yes.
right? So in density base, the basis is different, not the distance. So the basis is what you call density. So we'll talk about that, you know, what's the difference between the two. So density based methods are based on the idea in which a cluster continues to grow until the density in the neighborhood satisfies a condition. So I live, for example, in this area and there's like population. So
Okay.
this cluster continues until the population becomes thin. Right? Do you agree? So if
Okay.
you're going on a highway and you start seeing, you know, a population, there can be even some houses far here and there, but you can see the big chunk, right? So you're looking at, you know, a particular density. You know what is density in physics?
Yes.
Mass per unit volume. If there are more things inside less area, that's more dense,
Yeah.
right?
More heavier.
More heavier. So the more dense it gets, the more things are inside that limited thing, right? Limited area. So density based methods are based on the idea that cluster continues to form until that certain density is available.
Can you give us an image example? Of
Example,
Image. By image.
by image, I'll show you. Do you see the image? I'm going to show it to you, the image, okay?
Okay.
But let me talk about a few more things and then I'll show you the image. So clusters are dense region. Clusters are dense regions in the data space separated by regions of lower density objects. Let me show you. When you go to Google Maps
Mm-hmm.
and you look at, you know, you zoom in near a city,
Okay.
you see some very dense areas with a lot of population and maybe becomes less and less, right?
Yes.
Have you seen Google Maps? Open Google Map and see how the city looks like.
No, I know how the city looks like.
So the more the population, the more the houses. You
Oh yeah,
see.
okay. The squares or yeah.
You see houses, right?
Yeah.
When you start going towards the end of the city, the number of houses becomes less and less and less.
Yeah. Yes.
But can you see that there are some areas which are connected to each other that are all very dense?
It is the center.
not just center, but it continues. They are all connected. Although they start at the end, they become thin, and it goes away, right? But there is like a connection between the whole dense area. So this whole connected dense area, you can draw a line of whatever shape that they are taking. This shape can be any. Look at Riyadh, look at the Mam, and whole eastern province, like going towards the coast. It goes like this, right? But in Riyadh goes in a slightly different way, and so on. So this is driven by density. So for example, here, do you agree that there is like a heavy dense area? Can you see a dense area?
Yes.
Yeah.
Although it looks maybe like a spherical shape, but do you see that it goes like this? Maybe there's like a mountain here and the population is going like this,
Yeah.
right? But you can track the dense areas. So what other thing do you notice other than dense areas? So how many clusters have we identified here by colors?
So 2
And what else do you notice here?
There is outliers.
outliers.
There are many points that do not belong to
And,
any of those two clusters.
and the two.
And why is
yeah.
that? Because they are not in the dense regions.
Yeah, and the dense region there are in somehow outliers, more less points.
Because their outliers are always few. But do you see that we try to capture those dense regions and we try to leave the empty regions, empty points which are far away. Okay. At least do you understand this thing? You remember partitioning rule? What was the rule for partitioning? One of the rules I told you? No, that's the way of creating it. The rule, there were two rules. Each cluster must contain a point and each point must
Less than the cluster.
no,
One
that is
cluster.
another
Go
thing.
to one
Each
cluster.
point must belong to,
One
One
cluster.
cluster.
not the rule here.
Oh, okay.
Partitioning has different and it goes to the application. What is the difference in application here? In partitioning methods, you are interested in finding groups and studying their characteristics, behavior. These groups for marketing, I need to know how I can create marketing campaign for this group and how I create marketing group, right? But if your objective is not that, you're looking for outlier detection. I need to see which one's behavior during exam is suspicious, or during insurance claims. You wanted to find this insurance claim looks suspicious. You're not interested in those big groups. You're interested in
Outside.
in K means, is there any outlier? There is no outlier. Every point belongs to
Group.
a group. So there is no outlier in K means, right? You cannot detect the unusual ones in K means.
Here we have.
Here you have, and even the farther they are, the more outlier they are, and the more they are of interest to you. Do you understand that? So clustering, how do you pick clustering approaches depends on your application. If your problem is not to identify groups, but your problem is to identify unusual points in your data, then what would you use?
Density.
Density-based clustering. Plus, if you're looking for non-spherical shape applications where spherical shape is problematic to you, again you can use density-based. But if you're interested in just overall grouping behaviors, then what would you use? The partitioning, the K-means. But if you're interested in more in-depth level of relationships, what would you choose?
Cluster.
The hierarchical, right? Multi-level cluster. When you say just big level is not enough. Like when we were analyzing the literature, it doesn't give us too deep insights when we say we have two big groups of literature. Because we say fine, forecasting, demand and transportation based literature, fine, we even know that already. Tell us, within this group how things are going, right? And then so we are able to say, okay, within transportation we have multimodal, we have sea-based transportation, we have land-based, and then within land-based we have those literature that tries to consider environmental issues. Some are not considering environmental issues. Those groups. So we wanted the full picture, right? So again, different applications. So the question is, you should then ask me the question: how do you decide that this point is not part of this dense region?
Uh,
This one is obvious, right? This
Yeah.
one is obvious, but why is it outside? And why we decide this to be inside?
and there is points that outside, but it's red.
Now I'm going to now talk about how do you decide which point is yes.
Because of the distance, they are so close to each other.
But how close is close?
You have to calculate.
It's a question, right?
I have
So
to-
if you find a house close to just outside the city,
Yeah.
would you call it an outlier or inside or outside the city? Khalas, Safa, Raqqa, we know it's inside.
Should I figure some centroid in
So I'm going to show you, we don't use the kind of a centroid thing, but different names, different approaches. So I'm going to show you conceptually how it works, okay? So, but isn't it an important question why this point is just outside, not decided to include, but this point we decided to include? Isn't it an important question to ask, right? There must be a basis or a mathematical basis for doing that, okay? So what we do here is, we need to now understand, and by the way, density-based clustering, I don't know whether we'll do it or not, but each of these methods we have a separate chapter on it eventually. Okay, so we are still going a little at a higher level discussion. Okay, so what do you see first thing?
neighborhood?
What neighborhood? What do you call this symbol?
Sigma?
No, it's there for the sum.
No, that something is,
Yeah, this is the sigma.
this is small, this.
Uh,
Do you know what those symbols are?
Alpha, beta, I think.
Alpha.
Alpha, beta, gamma, delta. So just like this, one of them, it's called epsilon. It looks like an E.
But it looks like the sigma.
I showed you, I've drawn the sigma.
Yeah, the
Looks
big one, the sigma.
Big, not only big one, but straight, not the curvy one. But it's called epsilon. In its name, just like alpha, beta, gamma, delta, we call it.
Epsilon.
If you're not happy calling it epsilon, just call it E. If you just E neighborhood, okay? But in reality, we call it epsilon. Okay, the symbol. So E neighborhood, let's call it E neighborhood. If you like to write E neighborhood, I'm perfectly fine with it. Just call small E neighborhood. Okay. Epsilon or E neighborhood, objects within a radius of E from an object. So E is supposedly is what? Is what? No, read it again. A radius of epsilon. So epsilon is a radius. So
What?
if this is an object,
Doctor, what does a radius mean?
محيط.
Oh, okay.
muhit,
قطر.
qatr.
Oh,
Muhit is from end to end, right?
Yeah.
It's like the diameter. Muhit is diameter or circumference.
Yeah.
Anyways, when you draw a circle, this is radius. This is qatr.
Yes.
So this is radius. So this is the length of the radius is E.
From the center of the radius.
From the center of the radius, or let's say for each object, I can draw a circle. Each object in my data point, I can stand, on that object and draw a circle of radius of epsilon. Yes.
How can I decide the border of the circle?
We just decide the radius and draw.
How?
Okay, let's assume that as a manager I've given you, we'll come to that, it's a very good question, okay? But for now, assume that you know this radius. So let's first understand this and then we'll see, who's coming up with this radius, okay? So, because it is an important question. But let's assume that you know this radius, okay? So for any point in my data, and I'm going to draw, I can pick any point. I can draw this circle of what radius? E, of size E. It could be 2 centimeters, whatever. Okay, is that clear?
Yes.
What is E? The radius. High density region is so anything in this radius is called the neighborhood of this point. You understand what neighborhood is?
Yes.
What do you call that in Arabic? Hi? Hi? Neighborhood. So I'm defining my neighborhood. That these are my neighbors. So I draw a circle and I say anyone inside this circle is my neighbor. Is that clear? Now, if in my neighborhood I have at least this much number of neighbors, which is minimum points. Again, I've given it to you. Let's say I'm calling it 3.
So
I'm going to call my neighborhood dense.
So E the minimum point.
E is the radius,
Yeah.
and min points is again given to you. And min points, so again, let's say E, I'm saying that, let's say 500 meters, okay?
Mm-hmm.
And min points means, let's say 3. Let's say 3. Pick any number. So if I find at least three points in my neighborhood, I'm going to call myself to be in a dense region. So I need to have at least this much number of neighbors. So I need to know whether I'm living in a dense neighborhood or in an open neighborhood.
Okay.
Right? So how do I decide? I need to see if I have minimum this much number of neighbors around me. So if I'm living in a jungle, I have nobody, 0 members, so I'm not in a dense region, right?
Yeah.
But if I'm living here and I have like 5, 6, 7 within this, which is more than the minimum, my criteria, then I live in a dense region.
Mm-hmm.
Right? You understand that? So you understand what is high density region. E neighborhood of an object contains at least min points. So E and min points are the input we have to give. Again, we have to know where we are coming up with this E and min points. But even if it is given to you, do you understand what they are? So can you tell me if this point is actually, it has a dense neighborhood?
No.
Why?
Because 1 is the minimum.
Because
It has 1. How many minimum do I need?
3.
What about the other one? The first circle that I've
It
drawn.
must to be in 500 meters. So it is not in the 500.
Which one? The above circle?
No.
The circle, whatever circle I've drawn. Okay? Imagine that circle is represented by 500 meters on a Google map. Okay? So, how many is the first circle? Do you think has a dense region?
Yes.
Why are you calling it a dense region? Because it has 3 points. So if it has 3 or more points, we call it a dense region. Okay. Now we have 3 more things to know. One is called the core point, a border point, and a noise point. A core point is exactly what you're looking at there. If you have drawn the radius around me, and my region turns out to be a dense region, then I'm a core point, because I in my neighborhood has enough points to call this region.
So you are the
I'm the core point. Okay, but let me draw something. Okay. Now imagine Now, do you see that this point is actually in this person's neighborhood?
Yes.
Right? But let me just draw the curve. Now, this point, look at its neighborhood. Do you see that this point's neighborhood is dense or not?
It's not. No.
Not.
Yes.
How many?
Yeah.
Because he's inside the other
There
circle.
is one.
No, just look at his circle.
Only
There.
only one.
He is dense.
Okay, when we have drawn this
There are
circle,
three. There
it
are
has
three.
1, 2, 3.
Yes.
But we have drawn around this point, it has only,
One.
oh sorry, 2. My bad. It should be part of this, right? Because there are 2. So this second point, neighborhood is not dense. So what is a border point? A border point belongs to a dense region, but itself not a core point, meaning that the point's own neighborhood is not dense. So I live like a border of a city. When you're looking at it from city, you know, I'm part of a dense region, but when you draw a circle around me, I do not have enough in my neighborhood.
Yeah.
So
That's called a border point.
the core point is the middle point.
It's like you're deep into the dense region.
Can you please go back to the previous figure, please?
I'm going to show you more examples and we'll be able to see this better actually. Okay.
So. the
For
one
example-
on the side.
For example, let's see this point, okay?
This one is border, right?
This one is border.
Yeah.
Why? Because when you draw, it does not have enough point
Yeah.
because of these empty region.
Yeah,
But when you draw around this point, you see a lot of points in here.
So it is dense.
So that point here is core point, and the one at the corner is the border point.
It's a border, yeah.
Right?
Can you
Let's
show
see
us-
more examples. And the noise
Yeah.
point is any point that you cannot call both core or border point is actually a noise point, which means that
outlier?
it has not a dense region by itself, and it's not even part of any dense region.
So it's outlier.
It's basically the outlier, the noise. So let's just see what I've tried to draw. Maybe you can see it here. So what is this point?
This is
Outlier.
no.
Noise. Let's
Okay.
first see the criteria. All these circles are 2 centimeters. And what is the minimum point criteria? 3. So let me just put my finger here. I cannot draw, otherwise the screen will go bad. But how many points do you have in this circle?
Four.
So is this? So what do you call this point?
Core.
But when I draw a circle around this point,
White score.
how many points does it have in its circle?
It's also a core.
Two.
No,
1, 2, 3, 4. Can you see?
Oh.
This is the point. What is the circle? I wish I could draw on it, but
Yeah, it's
you will kill me. So I cannot draw. Use my pen. So just keep my pen here, okay?
Okay.
Can you see this circle around it?
Yeah.
How many points inside that circle?
2.
Are you sure to? Look. This is my circle. I'm drawing this circle. 1, 2, 3, 4. All 4 of them. No, why are you drawing it like this? This is the circle. This is the circle. This one? This is the center of the circle.
Okay.
When you draw the center of the circle, you don't draw a circle like this. You don't draw a circle like this, you draw a circle like this.
Okay.
So if you see this point, this is the circle, this is the circle, this is the circle. I'm drawing,
The big one.
right? This is the
Okay,
circle.
yeah.
And 1, 2, 3, 4 points.
Okay.
But what about this point? Can you see the circle?
Yes.
How many points inside in there?
2.
Which means that it is border point, it's not a core point. Right?
So
Now,
the
you can see one more thing here, which I want you to see.
so the core is when the center and there is
Enough point inside.
yeah the highest point.
You know, we have decided min points, 3, at
Yeah.
least 3 or more.
Okay. Yeah.
Now, do you see one more thing? How are we creating dense regions? How do you think we are creating dense regions? Do you see at least a couple of dense regions in there? Now, not one circle.
Yes.
Why have we separated these two regions? How
Dense-
are we creating?
Because they are far away, so I can categorize them as a.
That's of course we can see, but give me more concrete method to join them together. Look at circles. Are they overlapping? Are they touching each other or not?
No.
Yeah.
Between them.
No.
No.
But here they are. There is connection between one or the other or the other. They are all connected. Do you see all connected circles?
Yes.
So when you have all those connected circles, they form actually the region.
Okay.
You see that? But as soon as you get disconnected, even if this connects, even by small amount, it's part of that region. But when you draw this one, they are not touching any circle of that region. Khalas, it's a new region. Right? Can you see that?
Yeah.
So this is how you form the shape of the cluster.
Doctor?
Yes.
Can you repeat the...
Okay. Around each point, do you see that there are circles? Okay, let me tell you. For this point and this point, their circles, are they on top of each other? Are they touching each other?
No.
They are not. Can't you see that they are on top of each other?
Yeah, they are next to each other.
No, they are. Look, this is the common region. They are on top of each other.
Can you draw a new one, Doctor?
Okay. So when I draw this circle and I draw this circle, are they touching each other?
No.
But when I draw this circle and I draw this circle, are there anything?
Yes.
So this is exactly what's happening here. So this is the common. They are touching each other like in this
Yeah.
portion.
Okay.
They are touching here on this region. So when you keep drawing like this, as long as they are touching, they form a region.
Tamam. Okay.
But you see that this group, there is no connection.
Yes, there is no connection.
So it means this is one region, this is another region.
Okay. And this one, the orange one, there are...
We haven't drawn it, so you have to draw it complete.
Oh,
We cannot. We're showing how you're building things up. Okay? Is that clear?
yeah.
Okay. Now, these are the original points, the blue ones, right? And then we applied density-based clustering, and the core points are green, the border points are
The
blue, and what is the outliers, red? Just mentally draw those circles and see, right? You can see that. Can you see the dense regions?
Yes.
And the blue ones do not, they are close to dense region, but they themselves are around them is neighborhood is thin, right? So my question goes back, why a certain point was decided to be put out and not part of the thing? Because
The circles, the overlap.
they are not part of even a core point.
Yes.
That is the region. You know, when you have those very close calls, it may be just outside, very close but not overlapping. Right? That's why that border point has nothing overlapping with the core point. Right? So based on the distance. Now the question is, where is that distance and min point coming from? It's the hardest question to answer. The hardest question to answer is that in clustering, one of the biggest criticism on clustering is that there is subjectivity into it. Like in k-means, we said how many groups. People have developed some algorithms which can suggest what is the good number of groups, but still there is an element of managerial decision, expert opinion into, like for example, customer segmentation. People who deal with that market, their opinion matters. That as an expert, I can see that there are at least 3 groups, but we do not know how to put my exact customers into this group or that group. But I have a sense of how many groups we have. You understand what I'm saying? Just like this, density-based clustering, distances and the number of points in the neighborhood is a subjective decision. Meaning that as a manager, it's my choice to call this dense enough or not. Right? So it is subject to criticism. In your opinion, as an analyst, you call 3 people around me a dense region, and I would say no, it has to be 5. It's not like that math where we all can agree.
subjective.
It is subjective. So the best approach to deal with such situations is when you are doing these clustering, this E10 min point 4, before you do the analysis, you get all the stakeholders sit together and argue, discuss, fight, but then you decide what is reasonable to your problem. Right? You understand? So people whoever is involved in doing clustering, who wants result out, needs to agree. What makes sense. Like if you're trying to do clustering in let's say cities in Saudi Arabia, you need to have people who deal with Baladia and government and to call what is dense region for them. Is it 10 houses? Is it 20 houses within a radius of what? So they are the people who deal with those problems on everyday basis, and they normally have a sense of what they call dense or not dense, right? Even for us, we go to Khobar and say it's dense, but you go to, let's say maybe here and back in a certain neighborhood, we say it doesn't look dense, right? So our mind is, even without giving numbers, has some sense of what we call dense and not dense, right? So but it is subjective. Unfortunately, there is no one answer to it. People have to agree, and agree meaning that they just have to talk and agree. What basis they want to use. Everybody is okay with that. So what are the three big chunks that we have discussed? Let's see if we have okay. So what are the three big chunks of clustering that we can do? Number one, partitioning, which is the most basic level one. Create spherical clusters, meaning that just based on distances. There is no concept of density moving in a very arbitrary shape, right? Where do you prefer to use k-mean clustering? In what kind of applications?
In unsupervised.
They are all unsupervised, okay? I mean, in terms of business application, where would you like to use? Where you are interested in knowing the behavior of big groups. You understand what I'm saying? So whenever you are interested in knowing how many big groups exist in my data, and then after finding those groups, I study their behavior, their characteristics. And again, remember the example. If you do not remember anything, just remember the example of market segmentation. Meaning that in market segmentation, that one outlier is not of your concern, right? If one unusual person is there in your market, who cares, right? Because why? Why I don't care? Because I'm creating my advertising based on those big groups.
Yeah. So I know that the target people.
I know the target people. I know that, okay, one big chunk behaves in a particular way, like the younger lot maybe, right? And maybe the older ladies. What the ad campaigns or marketing campaign I create for you is not the same for, those middle-aged or old-aged ladies, right? So their schemes will be completely different. But understand the purpose. We are interested in not individuals. We are interested in those big size groups, right? So this is when you have this purpose, then you use k-means. But if you are interested in those unusual ones, what do you use? Density based, because it allows you to identify those outliers in your data. But if you are interested in not just simple level 0, 1, 1, big grouping,
More detailed.
detailed, multiple depth. Okay, within each group, tell me more. Within each group, tell me more. Within each group, tell me more. The differences within each group, right? Then you use hierarchical clustering. And I showed you the example of literature analysis where if we could have done just k-means. K-means just told us two big chunks, but what do we do with that? So in order to find more levels, we actually use hierarchical, where it went down to the relationship between even two things. Now I wanted to show you one more thing which makes it very interesting, the hierarchical, which I skipped, but I think now it's a good time to talk about that. Okay, maybe let me use the example of my paper. Okay, let it run. Even if you see, you can find the distance between even individual points. This is showing the distance between point 1 and 2, point 2 and point So it can tell you as deep as comparison between individual points. You understand what I'm saying? So these 2 points are closer to each other, closest to each other, but then the next closest to them as together is point number 22. Can you see? Can you read this then? And then overall 7, 8, 27. Then you can give. So you can even do comparison between point and point. You can see which two. So if you see the paper that I showed you, we can actually see that out of those 200 papers, these 2 papers are very, very identical, very close to each other in what they are doing. You understand that?
Yeah.
So it can go as deep as top level to right down to comparing between 2 individual points, in 2 individuals. Okay, and you will see that when we will inshallah do hierarchical clustering, how interesting it becomes. It becomes even funny at a point, to a certain extent. Okay, so we will see how hierarchical is done. Next, inshallah, we will do k-mean clustering. We'll start the partitioning method, and then within partitioning we'll see the next is the real thing, meaning that it's better if you bring a tab or a paper or pencil, whichever you prefer, because next we'll be doing things by hand. And please bring calculators, either calculators or your cell phones or whatever, right? So next time it's a hands-on thing. So where do we start next time? We'll start with partitioning methods. So we'll do partitioning methods. We'll do then for sure hierarchical one, possibly density based, depending upon the time. Okay, and this will be actually till your midterm. Okay, till midterm. So you already have the big picture. Now it's all about the details. Meaning that partitioning, I know conceptually. Now I'm going to do it by hand. Doing by hand. Okay. So do you want to start the partitioning method now, or
It's okay. As you wish. Next.
no? Let us just get things going a little, because we only have one class. So I don't want to push too much things towards midterm. Okay. I'm going to give you a bigger idea so that next time we come, you have enough time to do by hand. Okay. So let us just at least get things going. So what is the formula you use to measure distances in partitioning method? What is the name of those 2 methods? So what is the name of, yes, for this? So what is the name of the 2 methods that you just studied that we can use to measure distance between 2 points? Manhattan and, remember these 2 names. Okay. You see it's written there, Euclidean. EU. Let me zoom, go full screen. Okay. So please, from now and onwards, especially for whatever we are doing, we have Euclidean distance, which looks, now I should not remind you, you should remember now. 2 distance is very important, 2 ways to measure distance. Euclidean, which is squaring differences and then taking square root. Okay. And then Manhattan is
Absolute value.
absolute value. Just remember this very well. So when I say now we have to take distances, I'll be asking you to use either Euclidean or Manhattan. So let us just go back and let's just talk about so partitioning method. And okay, so we are going into partitioning method, and we are going I'm just going to give you an introduction to its algorithm now. So one thing I told you, that you start randomly and then you iteratively improve. This is what I said. Okay. When I was talking about partitioning method in the beginning, I said you first distribute your points randomly and then you iteratively improve. So it's the same thing. So we are going to start here, and we will first talk about, there will be 2 methods that we will study. One of them is called k-means partitioning method, and then we'll talk about something called k-medoids. Both are partitioning methods. Both do exactly the same thing, slight differences. Both have their own pros and cons, their own advantages and disadvantages. But I can tell you that 99% of the clustering these days are done on k-means is the most common one, extremely common one. And why people use it? Because it's very easy to use and very efficient. It has a lot of advantages. That is why even for very simple applications to very advanced applications, the first thing that anybody, a name comes to anyone's mind when doing clustering is k-means. People normally start here. If the k-mean doesn't work for them, then they look for another option. Okay, k-means. So we are going to talk about k-mean clustering and its limitations. So this is how it works. So in order to understand this algorithm, I want you to remind yourself about few things. Okay, so you see here something is written here, distance. So do you remember this distance matrix? There was a term used called D, 1, 2, 2, 3, all those things.
Yes.
Remember that?
No.
Okay. You just remember that I said that distances can be found using two formulas. What are those formulas?
Euclidean, Manhattan.
So we are asking about those distances. So what is the formula for Euclidean distance with two features?
Square
x1 minus
x2
square plus
y1 minus y2.
two features, right? And you're trying to see the difference between them.
So this is the compute distance over the center.
Yeah, you just do computing the distance. You understand what computing distance means?
Yeah.
x1 minus x2 square, y1 minus y2 square. Compute distance from all points to all k centers. So you have to compute distance from all points to what? All points to what?
Center.
It says k centers, which is the centroids. Then you should ask this question, where has this centroid come from? Where have this centroid come from? I told you in partitioning method you start where? In the last, I repeated that. Let me repeat again so that you are able to. You start randomly and then you improve.
Yeah.
Just see what I just said. You start randomly and then you improve. So you have to find distances from all points to k centers. So where do you think these k centers are coming from? I told you we are starting.
Randomly.
From random.
It means that k centers are picked.
Randomly.
Random.
You close your eyes and pick random.
Okay.
That's how random it is.
Can I choose?
Yeah?
Can I choose?
Yeah, anyone can choose any point. But in k means you to be easy, you pick one of those points as the random centers in your data already. You understand that?
Yes.
So if you have 20 points and you have two clusters to make, so you pick any 2 points as random clusters. Everybody understand how we pick the initial
Then
ones?
I figure the patterns or the.
You can improve your scenario to have less iterations by drawing those points and then see, I see a group here, I see a group here. So one may be random point from here, one random point here. It will reduce your iteration. But nobody is stopping you from picking any 2 points, and it will eventually take you to the same answer. The only thing is that the iteration may take long, yes.
But for example, Orange or Power BI or it can be figured that centers.
No, they start with random points.
Yeah, they start, but they can make two cluster, and I think. it is-
So if you suggest 2 clusters, they will pick random points, but the end answer will always be the same. Whether you use orange, you do it by hand, you will reach to the same answer because
Yeah.
of the math, the
Yeah.
math behind
They're fast.
it. Okay, so you understand the first point.
Yeah.
How do you compute distance? By using or Euclidean distance. And the distance has to be taken between every data point and
Another point.
these case centers, which are picked
Point of contact.
randomly. Then assign each point to the nearest case center, meaning that I have these are the two centers and this is the point. I measured the distance and I measured the distance. This distance turned out to be 5, this distance turned out to be the 7. So what does this second line is telling you?
Assigned to the nearest.
Assigned to the nearest. So I say, oh, this point belongs to this cluster. And then compute the average of all points assigned to all specific case centers. So eventually what I'll do, I'll be doing this for all points. So some points will be assigned to one center and some points will be assigned to another center. Right? So this is done. Once this is done, the next point is compute average of all points, average of x, average of y, average of z. You know, the average x value, y value, z value. So this will give you a new center. Right? And then it says replace the case centers with the new averages. Right? So new average becomes new centers and then you repeat the process. You will see. You will only see how we reach the end. But this new average becomes the new center, and again you compute the distance, you assign the nearest one, and then you keep repeating until when you find the next time average in the next loop, the average values don't change. They still stays the same as the last iteration.
So this is the correct case center.
Then these are the actual case centers. Wherever you start, you actually reach a point where the results will converge, and no matter how many times you iterate, the average does not change. X, Y, Z, how many characteristics. Okay? So this is the basis, and inshallah next time what we will do is we will take a real example and then we will try to do it by hand. Inshallah we'll try to do things by hand, and then we'll try to if like we can try compete with Orange and see if we are getting the same answer. Okay? I think we should stop because I see some miskin faces now. The faces are getting longer and longer and longer. And it's a long day for all of you, so I think you may have taken other courses. So, I have a lot of, I don't know what you call this. In Urdu we call it akhlaqi pressure, like it's putting pressure on me, your hanging faces. So I'm going to stop now, okay? But please